Good morning. It's November 27th, and this is your daily brief in science. Here's everything you need to know. A potential dark matter signal is drawing attention. Researchers report a 20 GeV gamma-ray excess in halo regions around the Milky Way that could align with WIMP annihilation, based on NASA's Fermi data. The study centers on a halo-like excess toward the galactic center, with an energy spectrum that matches WIMP masses around 500 proton masses and annihilation rates within theoretical expectations. The paper, titled 20 GeV Halo-like Excess of the Galactic Diffuse Emission and Implications for Dark Matter Annihilation, is by Tomonori Totani and published in the Journal of Cosmology and Astroparticle Physics, with funding from JSPS and MEXT Kakenhai. Validation will depend on ruling out astrophysical sources and achieving consistency across independent observations and methods, since consensus about the halo excess and the longer-standing galactic center excess remains unsettled. While the interpretation is compelling, alternative astrophysical explanations cannot be fully ruled out without further verification. The findings are described as a strong potential indication rather than a confirmed discovery, awaiting independent verification and scrutiny of alternative sources. Next steps include independent verification of Totani's analysis, replication with different halo models, and additional data from Fermi and ground-based observatories like the Cherenkov Telescope Array. To reduce background, the analysis excludes the galactic plane and focuses on halo structures to isolate a potential dark matter signal. If real, the signal would come from particles roughly 500 times the proton's mass, though alternative explanations and background emissions must be ruled out. Future facilities, such as the Cherenkov Telescope Array Observatory, are expected to improve gamma-ray sensitivity and enable more detailed scrutiny of the halo signal. A point of contention is Totani's exclusion of the galactic center from the analysis, with some researchers arguing this could bias results, while others note that multiple analyses have not consistently replicated the excess. The study builds on a decade and a half of Fermi data and reflects collaborative work among gamma-ray researchers, published in the Journal of Cosmology and Astroparticle Physics. In a rare nighttime liftoff, Korea's three-stage Nuri rocket carried the 516-kilogram KAS-500 satellite and 12 CubeSats into a roughly 600-kilometer sun-synchronous orbit, with KAS-500 making contact with a ground station in Antarctica about 40 minutes after launch. This mission is the first Nuri flight since May 2023 and the fourth since the program began in 2021, following earlier attempts and failures. Future launches are planned for 2026 and 2027 as part of Korea's multi-year push to advance space technology, reduce reliance on foreign launch services, and close the gap with Asia's leading space powers. Yoon Young-bin, the KASA administrator, called the mission a milestone for the agency's development and for the collaborative approach surrounding the flight. President Lee Jae-myung emphasized that private sector involvement demonstrates Korea's scientific and technological independence and will underpin future generations. HD Hyundai Heavy Industries operated the launch pad, and the Korea Aerospace Research Institute streamed the event, highlighting private sector participation across the launch process. Science Minister Kyung-hoon Bae described the mission as a turning point for Korea's space sector, noting Hanwha Aerospace assembled the rocket under a technology transfer from KAR-1. For the first time, Hanwha Aerospace oversees rocket production, assembly, and supply chain management, with KAR-1 in a supervisory role as Korea shifts toward private sector leadership. The government transferred technology to Hanwha Aerospace to boost private sector space capabilities and strengthen Korea's aerospace competitiveness. Prime Minister Bae Kyung-hoon outlined Korea's goal to become a top 5 space power, pursuing next-generation launch vehicles and ambitions for moon and deep space exploration. A brief delay occurred due to an abnormal pressure sensor signal on the umbilical, shifting liftoff from early evening to late night, but the launch proceeded successfully. Industry Context notes SpaceX's dominance and a global supply gap in medium to large launch services, which Korea aims to fill with competitive options for international operators. A new front in Mars science opens as NASA's Perseverance rover records audio evidence of electrical discharges on the red planet, interpreted as miniature lightning mainly during dust storms and dust devils. The findings, published in Nature and led by Baptiste Chide with collaborators Ralph Lorenz and Frank Montmessin, place Martian atmospheric electricity alongside Earth, Saturn, and Jupiter as worlds with measurable electrical activity. Laboratory simulations and data comparisons show the sounds align with expected interference from nearby discharges, supporting a triboelectric discharge interpretation. Robustness is bolstered by replication of triboelectric discharges in the lab and a Perseverance SuperCam replica on the ground linking wind-driven charging to the observed signals. The report situates Martian electricity within a broader context of related work cited in the journal Nature. Some scientists caution that the evidence comes from a single rock analysis instrument not designed for lightning detection, leaving room for debate until more instruments verify the findings. Independent scientists acknowledge the data are persuasive but originate from one instrument, underscoring the need for verification with additional instruments to conclusively confirm Martian lightning. The researchers describe the discharges as mini-lightning, capable of producing audible shockwave-like signatures similar to Earth electrostatic discharges. The Nature report suggests these discharges could generate highly oxidizing atmospheric compounds, potentially affecting organic molecule destruction and methane dynamics. The largest discharges are estimated at about 40 millijoules, producing audible, shockwave-like signatures detected by Perseverance's microphone. Two ancient hominins shared a region more than 3 million years ago, and this story turns on a distinctive foot in a new species. A 3.4-million-year-old Bertel foot shows an opposable big toe tuned for tree climbing, but with a shape that can support upright walking and propulsion driven mainly by the second toe. Recent fossils from Woranso-Mille, Ethiopia, including a skull and jaw with 12 teeth, support assigning the Bertel foot to Australopithecus diaremida and suggest a diet focused on trees, shrubs, fruits, and leaves rather than the broader woodland diet seen in Lucy's species. The findings, published in Nature, provide formal evidence that A. diaremida and Australopithecus afarensis lived in the same region and era. This implies coexistence with different locomotive and dietary adaptations, rather than a single straight lineage toward bipedality. Experts say the discovery points to multiple experimental paths to bipedality in early hominins, and invites reevaluation of how coexisting species navigated shared environments. The work challenges a linear, single-line evolution narrative and supports the idea that several closely related hominins inhabited nearby spaces during the Pliocene. Despite their geographic and temporal proximity, A. afarensis and A. diaremida may have reduced food competition by occupying different ecological niches. CT scans and tooth development studies indicate juvenile growth patterns in A. diaremida were consistent with other early hominins, suggesting shared growth biology. Woranso-Mille provides clear evidence that two related hominin species coexisted in the same region and period, with dental, dietary, and foot morphology painting a picture of differing lifestyles. The study underscores diverse evolutionary paths and the coexistence of diaremida and afarensis in overlapping habitats, with dental and dietary data supporting distinct locomotion and foraging strategies among contemporaries. A new image from the Gemini-South telescope in Chile reveals the Butterfly-Nebula, a butterfly-shaped bipolar nebula about 2,500 to 3,800 light-years away in Scorpius. At the center sits a white dwarf that has shed its outer layers, with the expelled gas forming the glowing wings that give the nebula its shape. The image was released by NSF NORLab and captured last month. The article includes a brief note on Keith Cooper, a UK science journalist and editor with a background in physics and astrophysics. Background notes explain that astronomer Fred Gillett conceived the twin telescope system to enable continuous hemispheric sky monitoring, with Gemini North later named in his honor after his death. Context on astronomical distance is provided, and the piece also celebrates the Gemini Observatory's 25-year milestone. First light for Gemini North occurred in June 1999 and Gemini South in November 2000. The telescopes use adaptive optics and near-infrared wide-field capabilities to complement each other's sky coverage. Gemini South stands as an 8.1-meter telescope atop Cerro Pachón in Chile, part of the International Gemini Observatory, operated with Gemini North in Hawaii, and funded by NSF NORLab alongside partners from Brazil, Canada, Chile, and the UK. Chilean schoolchildren selected this butterfly nebula image to commemorate 25 years of operation by the International Gemini Observatory, highlighting educational outreach. The 25th anniversary image stems from the Gemini First Light Anniversary Image Contest under NORLab's Legacy Imaging Program, emphasizing student involvement. The anniversary initiative underscores an educational outreach component as Chilean students chose the entry for the milestone image. NGC 6302 formed when a sun-like star expanded into a red giant, ejecting outer layers about 2 millennia ago to create a dense equatorial ring and perpendicular wing-like lobes. The article notes AP content sourcing and presents a science feature centered on astronomical discovery and educational engagement. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.